5,000 meters above the Italian Alps. The air is so cold it burns. February 2026. The world is watching. Below these jagged peaks lies one of the most ambitious infrastructure projects in Olympic history. A €5.2 billion gamble that Italy is racing against time to complete. This is not just about sport. This is about tunneling through some of the hardest rock on Earth to connect a nation, about transforming impossible into reality, about engineering at the absolute edge of human capability. The drone plunges, clouds shatter like glass. The Milan-Cortina corridor reveals itself, a serpentine artery carved through the Dolomites, connecting 8 separate Olympic venues spread across 8,500 square miles of northern Italy. Officials called it innovative. Engineers called it insane. What they're attempting here has never been done before. At this scale, at this speed, in these conditions. The helicopter thunders overhead, its rotors beating against the mountain wind. Suspended beneath it, a 10-ton steel cable swings like a pendulum, destined for the cliff face ahead. This is Supply Line Alpha. Everything that goes into that mountain, every bolt, every concrete segment, every drop of fuel, comes through corridors like this. The logistics are staggering. €3.5 billion in public infrastructure. 1,700 kilometers of new fiber optic cable. 900 kilometers of high-speed rail upgrades. Tunnels that weren't supposed to be ready for another decade, now being finished in months. The machine doesn't care about deadlines, it only knows stone. The tunnel mouth yawns open, 20 meters wide, steam pouring from its depths like the breath of some ancient beast. The hydraulic gates groan, metal scraping against metal, opening slowly to reveal the industrial hell inside. Orange floodlights cut through blue mountain shadows. This is the entrance to the deep core, where the real work happens, where men and machines wage war against the Alps themselves. Inside, the temperature drops. The air tastes of diesel and wet rock. 2 inches of icy water cover the floor, disturbed only by the massive wheels of the tunnel boring machine as it grinds forward. This is a Sky Dragon Class TBM, a Chinese-designed beast that cost €40 million and weighs more than the Eiffel Tower. Its cutter head alone is 30 feet in diameter, studded with 300 tungsten carbide teeth designed to chew through granite rated at 200 megapascals, rock so hard it can shatter steel. But the Alps are harder. A worker adjusts his oxygen mask, base caked in rock dust that's worked its way under every seal, into every crease of skin. These are the sandhogs, the tunnel elite. Men who spend 14-hour shifts in conditions that would break most people in 14 minutes. The noise is constant, a grinding roar that you feel in your bones before you hear it. The dust hangs in the air like fog, making every breath a conscious effort. Helmet lights cut through the darkness, creating ghost shadows that dance on the tunnel walls. The drill bit makes contact. 200 megapascals. The rock resists, then surrenders in a cascade of white sparks that illuminate the darkness like a welder's torch. Each rotation of that bit generates enough heat to melt aluminum. Water sprays continuously, cooling the metal, suppressing the dust, fighting the constant threat of fire in an oxygen-starved environment where one spark could trigger a catastrophe. The rock cracks, not where they expected. A fissure appears in the granite face, and suddenly water is spraying out under 5 bars of pressure. A jet of glacial meltwater that's been trapped in these mountains for 10,000 years. The temperature of that water is 0.5 degrees Celsius. Touch it and you've got maybe 3 minutes before hypothermia begins. The crew moves fast. A drainage intake is positioned. Hydraulic seals are activated, and within 90 seconds the water's being channeled away, down through 3-foot diameter steel pipes to the pump station 600 feet below. Down in that pump station, 3 colossal vertical pumps vibrate with a frequency you can feel in your teeth. They're lifting 6,000 liters per minute, fighting gravity, fighting the mountain itself. The pressure gauges tremble in the red zone. This is the knife edge. They walk every single day. Too much pressure and the pipes rupture. Too little and the tunnel floods, drowning months of work in hours. The cost of failure is not just measured in euros. In early January, a security guard died at a Cortina construction site during a sub-zero overnight shift. Heart attack, they said. Natural causes. But everyone knows the truth. This work kills. The altitude, the cold, the pressure, the endless noise that never stops. Not even in your dreams. Italy has pledged that these will be the most sustainable Olympics ever. But sustainability is a word that means something different when you're 2 kilometers inside a mountain. Breathing air that's been scrubbed by machines, drinking water that's been trucked in, living in a world where sunlight is a memory. The TBM gantry is a factory that lives underground. Robotic arms move in perfect synchronization, greasing the main bearing gears with thick yellow compound. The central gear assembly, 30 feet wide, begins its rotation. This is the 2-minute pivot, the moment when 15,000 tons of machinery rotates 2 degrees, repositioning the cutter head for the next advance. The sound is primal, a grinding mechanical symphony that builds from a low groan to a shriek as the motor reaches full torque. The cutter head engages. Rock explodes. Chunks the size of refrigerators are carved from the face and tumbled onto conveyor belts that snake back through the machine's intestines, carrying debris at 5 meters per second toward the rear. The TBM advances at an average of 18 meters per day. On a good day, when the rock cooperates, when the equipment doesn't break, when ancient ice pockets are discovered, when fault zones don't appear, when the mountain decides to let them through. But the mountain is not cooperating today. The geologist sees it first on his handheld ultrasonic scanner, a red laser grid projected onto the rock face, showing stress concentrations that shouldn't be there. The readings are off. Way off. This section of granite is under pressure, compressed by forces that have been building for millennia. They call it a fault zone, a polite term for a geological time bomb. The rock bolting machine fires. 10-foot steel bolts are drilled into the unstable ceiling at 3-second intervals, each one followed by a resin cartridge that explodes on contact. Chemical adhesive flowing to lock the bolt in place. The smell is acrid, chemical burning the inside of your nose. They install 200 bolts in an hour. It's not enough. The ceiling is still moving, micro shifts measured in millimeters that could become catastrophic in seconds. Shotcrete. The solution is always shotcrete. A heavy-duty arm swings into position and begins spraying liquid concrete onto the cavern roof at 15 bars of pressure. The concrete hardens instantly, steam rising from the chemical reaction. They spray until the roof is covered, until the rock can't move anymore, until the mountain is contained. But they've lost 2 days of advance. 2 days times 18 meters. 36 meters behind schedule on a project where being behind schedule is not an option. The 2026 Winter Olympics opening ceremony is 8 weeks away. 8 weeks to complete 57 kilometers of tunnel, install the rails, string the electrical lines, test the systems, and prove that this insane plan actually works. Italy is betting everything on this. The government says it will generate $5.3 billion in revenue against $3.5 billion in costs. The multiplier effect, they call it. Jobs. Tourism. Infrastructure that will serve northern Italy for generations. But scratch the surface and the numbers get uncomfortable. France hosted the Summer Olympics in 2024 and got a GDP boost of 0.07%. 0.07. For 10 billion euros in spending. The Olympic curse is real. Ask Athens. Ask Rio. Ask any city that's bet its future on 2 weeks of sport and a legacy of debt. But Italy isn't backing down. Transport Minister Salvini stands at a press conference in Rome's Ama XXI Museum and declares, what seemed impossible until recently has become reality. He's talking about the tunnels. The 2 small bypass tunnels near Cortina that were inaugurated on January 26th after years of delays. The Highway Authority chief stood on a red carpet as an alpine marching band played and a bishop blessed the construction with holy water and prayers for the games. 20 miles of winding mountain road bypassed. Villages that have been traffic choked for decades, finally getting relief. Our goal was to complete this project for the Olympics, he said. And you could hear the exhaustion in his voice, the weight of a deadline that never stops coming. The TBM interior is a maze of hydraulic lines, electrical racks, and machinery that has no business existing this far underground. The operator sits in a high-tech cabin surrounded by 12 screens, each one showing a different system parameter. Cutter head torque, advance rate, hydraulic pressure, rock density, methane levels, water ingress, temperature. The list goes on. One screen shows an X-ray style view of the TBM's alignment inside the mountain. A 200-foot machine that must be positioned with millimeter accuracy or the tunnel will curve, will miss its target, will emerge a kilometer off course on the other side. The small 4-legged maintenance robot walks the catwalk above. its camera scanning for microfissures in the TBM steel frame. The machine found 3 yesterday. 3 hairline cracks in welds that were supposed to last 10 years. They're 18 months old. The stress of pushing through the Alps is eating this machine alive. Behind the TBM, the finishing work begins. The segment erector, a massive robotic arm, lifts 20-ton concrete segments with vacuum suction cups and rotates them into position with servo motor precision. Each segment is part of a ring, and each ring moves them 2 meters closer to completion. The segments lock together with rubber gaskets that compress into watertight seals. This is the permanent tunnel, the structure that will exist long after the Olympics are forgotten, that will carry trains at 300 kilometers per hour through the heart of the Alps. The rail installation crews work in shifts that blur together. Welding crews join rail sections with thermite welds, creating continuous ribbons of steel that stretch for kilometers. The molten metal glows white-hot, then red, then dull gray as it cools. Overhead, electrical teams install copper catenary wires, the power lines that will feed the trains. Rome-based Terna has buried 130 kilometers of power lines underground to minimize visual impact, to preserve the alpine aesthetic that tourists pay premium prices to experience. But there's a darker side to this story. In early February, just days into the Olympics, suspected sabotage hit the rail lines. 3 separate incidents. Cables cut. Signals damaged. Delays of up to 2.5 hours on the main routes connecting Rome to Milan to the Olympic venues. The investigation is ongoing. No arrests yet, but the message is clear. Not everyone wants these Olympics to succeed. The ventilation system roars to life. 20-foot axial jet fans accelerate to full speed, drawing dust clouds toward exhaust shafts. The air in these tunnels is changed completely every 45 minutes. Without that, the workers would suffocate. Carbon monoxide, methane, diesel fumes, rock dust. The list of things trying to kill you underground is long and creative. The digital control hub monitors everything. Hundreds of green and yellow LEDs blink on server racks, processing data from sensors embedded throughout the tunnel network. Temperature, pressure, air quality, structural stress. Every metric is logged, analyzed, compared against models that predict how the mountain will behave. Because the mountain is alive. It moves, it shifts, it breathes. And if you don't listen to what it's telling you, it will crush you. The CCTV cameras rotate on their mounts, scanning every meter of finished tunnel. The security feeds go to a control room in Milan, where analysts watch 20 screens simultaneously, looking for anomalies, for threats, for anything that shouldn't be there. This is post-9/11 infrastructure designed with terrorism in mind, with redundancy and fail-safes and emergency protocols that everyone hopes will never be needed. The floor polishing machines buff the concrete until it reflects like glass. It seems absurd, this attention to aesthetics in a tunnel that exists purely for function. But this is Italy. Even infrastructure has to be beautiful. The Milano Cortina logo is applied to finished segments, smooth, white vinyl adhering to gray concrete. Red, white, and blue. The colors of a promise that's 2 months from being tested. The Grand Cavern Station is a cathedral of engineering. 40 feet high, carved from solid rock, with architectural lighting designed to make arriving passengers feel like they've entered something sacred rather than something structural. The platform edges are being painted safety yellow by automated robots. Emergency boxes are tested, their alarm systems connected to a network that spans the entire Olympic corridor. The crossover passages allow movement between the north and south tunnels. Redundancy built into the system so that if one tunnel floods or collapses, the other becomes a rescue route. The ventilation shutters are massive steel slats that can seal off sections in seconds, creating safe zones where workers can shelter during emergencies. The rail is poured in sections, liquid concrete smoothed by vibrating screeds guided by laser precision. The laser never lies. It projects a red dot that the machines follow with robotic obedience. This is the foundation for speeds that would have been unthinkable a generation ago. 300 kilometers per hour through tunnels carved from mountains. The margin for error is measured in millimeters. The first test train appears as a distant light, a white beam cutting through darkness, growing larger, closer, faster, 320 kilometers per hour. The sound arrives before the train does, a rising electric whine that builds to a roar. The silver Olympic bullet train, purpose-built for this corridor, rockets past in a blur of motion and wind. Sparks fly from the pantograph as it contacts the catenary wire. blue-white electric arcs that dance across the tunnel ceiling. Inside the empty cabin, the ultra-modern seating waits for passengers who will experience this journey as a smooth, quiet ride through the Alps, oblivious to the violence required to create it. The train exits the mountain into blinding sunlight, emerging in the snow-covered valley like a bullet from a gun. The bridge it crosses is 300 feet above the valley floor, concrete piers driven deep into bedrock. A structure designed to survive earthquakes and avalanches and the weight of trains that will pass over it 10,000 times a year. The emergency brake test sends sparks and smoke billowing. The wheels lock, the train shrieks, and the smell of burning brake pads fills the air. This is the test that proves the system works, that proves passengers can be stopped safely if something goes wrong. Fire evacuation drills send workers scrambling through service tunnels to pressurize safe zones. The doors seal with a hiss. Inside, the air is clean, the pressure positive, the emergency supply sufficient to keep 100 people alive for 72 hours. The backup generators and air tanks are staged every kilometer, redundancy layered on redundancy. The digital control screen flashes green. All safety tests passed. The signal changes from red to green. Permission for full-scale operations. The second test train passes the first in the parallel tunnel. 2 trains at 600 combined kilometers per hour separated by meters of rock and concrete. The sound is massive, a double whoosh that rattles the walls. The mid-mountain cross is where the tunnels intersect, a cavern where engineers can move between systems, where the north and south bores meet in a cathedral of gray stone and amber light. Above it, a ventilation shaft rises 1,000 feet straight up to a tiny circle of daylight. The cameras follow that shaft, accelerating upward, breaking out onto the snow-covered peak under starlight. The Milan Cortina tunnel portal at sunrise is where promise meets reality. Italian and Olympic flags wave in the golden light. A line of 100 workers stands in clean uniforms, saluting as the first official train passes. These are the men and women who made it possible, who gave years of their lives to dig through a mountain, who risked everything for a deadline imposed by sport. The bishop who blessed the construction would say it was divine intervention. The engineers know better. It was steel and concrete and sweat and blood and mathematics and luck. The pristine tunnel stretches into the distance, every meter of concrete perfect, every rail joint aligned, every electrical connection tested. A gold commemorative plaque is mounted on the wall, engraved with names and dates, and the promise that this was for the 2026 Winter Olympics, for Italy, for the future. But the promise comes with footnotes. Most of the planned tunnels and bridges, presented as the legacy of these games, won't be ready for years. The controversial sliding track in Cortina was finished at the last possible moment, over budget and behind schedule.